Good afternoon, ladies and gentlemen of Altitude Honors. Good to have everybody here today, except for Connor. He just left us. But we'll try to get by without him. What we did is we went through number 17 yesterday, and so what we're doing is we're getting into the problems 18, 19, and 20. And I had a student in 7th period, Brian, who remembered a cartoon I showed this class pretty recently. Remember the cartoon that I showed in this class? It was Hell's Library. Yeah, you remember that, right? And so he caught that. He says, "This is we're back to the devil's library here." Yeah, kind of. Word problems. So it was good for him to make that connection. But anyway, what I'm going to do for this one is we're just going to go through these together, see if we can figure out what's happening and participate as much as you can. I'm going to get credit where I can for helpers on these. And then we get to problem 21, and problem 21 is really pretty easy. But these ones here, we got to change English into math, and rational equations sometimes aren't the easiest to understand anyway, and then you complicate this with the situation. So what we're given right now is we're trying to find a driver's average speed during the acceleration. So we have distance. What do you notice about this problem? We got a formula: distance equals v sub 0 t plus 1/2 at squared. V sub 0 is the initial speed of the race car. Anything you notice about this?
It's a physics equation.
It's kind of a physics thing, right? So it's an application, right? And what happens is that this involves really one of the most used practical applications of algebra in this very problem, or the concept of what distance is. How do you find what is distance? There's a formula that says d for distance equals
Rate times velocity?
almost, okay? You almost had it. Did you have it, Marcus? Look like you're about ready to hit. So Ben was right on the precipice of it. It's distance equals rate times time, right? D equals RT. So very, very famous practical application. And what we're trying to do is we're trying to find, what are we trying to find here? Speed, right? So what in our equation here is analogous to speed? Rate. So we're going to go ahead and solve for rate. So rate is going to be equal to what?
T over D.
Distance divided by time. Okay, so, and we're going to go ahead and I'm just going to go ahead and change this out because that's what we're being asked to speed. So I'm going to say speed is equal to distance over time. Okay? And in the context of this problem, what would we do to get distance over time? Okay, 9 would be the time, right, according to this. But what we're going to do, we're going to do the formula to get a formula with the information given that is distance over time, or expression, this distance over time.
We're going to plug in the values in the more complicated equation.
Okay, what I'm going to do is I'm going to recommend taking this thing right here and replacing this right here. You see what I'm doing? So how would we write that out? V sub 0 t plus 1/2 at squared over t, which is a rational expression that is distance over time. And what would be the speed according to the simplification of this? I'm going to go ahead and kind of expand a little bit. What that's equal to is v sub 0 t over t plus 1/2 a t squared over t. That's what that is. So what does that simplify to?
V sub 0
Okay, v sub 0 plus
1/2
1/2
a times t.
a times t. Is that right? And so if we just plug in, we should be able to figure this out. So now we have our function, our formula. So how do we find the average speed? Well, speed is going to be equal to, I would say, average speed at this point. So what numbers do we have here that we can plug in?
75.
What does 75 represent?
The initial velocity.
V sub 0, right? Our starting velocity is 75 plus 1/2 a, and what is a?
4.
A is 4. And what happens is you get, and you're going to do this, and probably Ben was saying physics, but also in calculus we talk about the relationship between position, velocity, and acceleration. And the units here, if you talk about the distance formula, this one here might be feet, this one here would be feet per second, and this one here would be acceleration feet per second squared. And so if you understand and also it helps you say accelerates 4 seconds at a rate of, and so this would be what your accelerate as. And how much, and what is t going to be here? 9. And so we can just go ahead and simplify that, and we get 1/2 of 4, 2 times 8, 9, 18 plus
75 is 90.
So 93, and it's going to be meters per second. Yeah, that's one thing. And do you go over that much in physics? Who's taking physics? Anybody? You are? Have you done this? Physics? So halfway makes sense. And in calculus, we talk about this too. And we develop like the equations to do the position, velocity, acceleration, do the derivations of those. Okay. Questions on that? This is one of these things in physics. These things, most of the time, they look harder than they really are. Once you think through them, okay? So let's go ahead to number 19. We have Juliana designing a circular track that consists of 3 concentric rings. Circular track 3. What does concentric mean?
Well, centric means center.
Centric means center, okay.
Con means width.
So with center.
Also circular track.
Okay, what it is, it's related to something we see over here on the south wall. My predecessor here, Mr. Calvin, was kind enough to leave these. Most of these deal with pre-calculus or trigonometry. Well, we have this thing here, coterminal, right? coterminal angles, it means angles that have the same ending place. Here's your terminal side. And so what does concentric mean? Circles that have the same center. So you talk about concentric circles, you're talking about a target looking thing, right? You got rings of a target. You got a center of the target and then the rings around it. So you're going to look like this. You have Juliana's track like this, and you got this here, and then you got this here. Now, have you ever thought, okay, you guys are track guys, Ben, right? Ben and Jay, right? And you notice you have on a track, the oval track, you have those lanes.
Oh, okay.
And so what we're doing today in this exercise, we're kind of making the same type of consideration. We have to think about the same thing. So really delving into the mathematics behind how you would design an oval track so the lanes would be, so you'd have equivalent distances. And of course they have to stagger the lanes to adjust for the increased length at a greater radius. Okay, so something to think about. And so what do we know? We're trying to find the ratio of the length of the outer ring to the length of the middle ring, and the length of the outer ring to the length of the inner ring. So we need to find expressions for lengths of inner ring, middle ring, and outer ring. And what information, what do we know about, and we're talking about a circular track. Now if they really want to make this more complicated, they could have made this an oval track, like a real track, but that would have brought a lot of other detail into it. They're not trying to teach. So, what will we do? What do we have to do to find the length of each one of these rings?
Well, first we start with the 90 meter, the inner ring.
Well, what we're going to do here is, so Ben is right about that, but right now, what I recommend doing first is find an expression for the ratio of the length of the outer ring to the length of the inner ring. So we're going to talk about an expression. And what I want to do is, before we actually plug in 90 for radius, I want to get an expression first for that. So how would you make an expression for the length of this inner track here? So length of inner track. How do we get a length of an inner track in terms of R? We'll say radius of inner track. Radius of inner track, we'll say, is R. What do we have to know to be able to find what the length of inner track is equal to what?
9.
How do you find length around a circle?
Oh, you multiply by 360. Isn't it by like pi or something?
What did you say?
Isn't it by like pi or something?
So yeah, so pi is part of that formula that does it. Yeah, go ahead, Mark. So continue. See, that's all you remember? Okay. So maybe we'll get it. So pi has something to do with pi. Good. There's a formula.
Radius times.
Okay, Julia just tossed out a little nugget here. She asked, isn't it the circumference? So yeah, what is our formula for a circumference? That's it.
Pi r squared, yeah, I was thinking.
Pi r squared?
Remember?
No, it's 2r times pi.
2r pi, yeah, so 2 pi r.
I knew that was
Because it's diameter, and diameter
a pi r.
2 pi r, okay, good. Were you given, when you took the, like the Algebra 1 star, did you have this formula on that, on your sheet? Because I'm looking at my pre-calculus one, I don't see it on there. I'm going to look up for the star formula chart, see if you have it. People don't remember formulas as well as they used to.
Well, that makes the formula.
You remember the pi r squared, you did remember that. That's going to come up next problem. Anyway, so here we have, this is the length of the inner track, and what's going to be the length of the middle track?
2 pi r plus 6.
So we have is length of middle track, and Julia says that's going to be 2 pi r plus 6. Does that make sense? Is that right? Okay. And length of outer track, what's the length of outer track going to be? Plus 12, you said, Marcus? Okay. Okay, is that right?
I don't know. It doesn't look right.
Doesn't look right. Ben is not comfortable.
I think so. Wait, no, because it says the radius is 6 meters bigger than, right?
Yeah.
So it's r, like in parentheses, r plus 6 and r plus 12.
Okay, so Ben is saying, and debate if he's not correct about this, R is saying that since we're replacing R, we got to make sure we put R plus 6 together. Does that make sense? Okay. Yeah, that's right. So now we have expressions for length of outer track, length of middle track, length inner track, middle track, and outer. So now we want to find a ratio for the length of the outer ring to middle ring. So I'm going to say ratio, and what is a ratio? A ratio is a what? There's an example right in back of you on that board there. That's pre-calculus. We were working on the law of sines, which is the ratio of the sine of an angle to its opposite side is equal to the sine of another angle to its opposite side, which is equal to the sine of the last angle to its opposite side. So what is a ratio? What is we talked about, what is a rational function? Fraction, thank you. Fraction, dividing, thank you. So ratio of outer ring to middle ring, of say OR to middle ring is going to be what? What's that fraction going to be? What's our outer ring?
2 pi
2 pi
times the quantity of r plus 12.
times the quantity of R plus 12, thank you. Using the language of quantity, that's really advanced, good. And then the middle ring is going to be this one, right? So we get 2 pi R plus 6. So is that an expression? And can this be simplified? Yeah. So we have R plus 12 over R plus 6. And then it's asking us the another for a ratio of the length of outer ring to the inner ring, right? So we have outer ring to inner ring. What's that going to be? 2 pi R plus 12. and 2 pi r. And what does that simplify to? R plus 12 over r. And then last thing it says, how many times longer is the outer ring than the middle ring and the inner ring? So what's this going to be if we plug in, now we plug in 90. So in this case, this is like the general expression, but the exact thing is going to be, what do we plug in now? For radius, for r. R is equal to what in this case? 90. R equals 90, and so we can plug this in. We have, oh, that cancels out too, right? Outer ring, middle ring. So what is that going to be? And what is that going to be when we simplify that out? 102 over 96, which is
1.065.
yeah, 1.06. It is, but I want the fraction form. We should get 17/16. Yeah. So 17/16. And then we have, last thing it says, middle ring. Oh, how many times longer is outer ring? So outer ring to inner ring, you should get 90, you should get 102 over 90, which is 17/15. Okay? All right, I want to thank you. You helped a lot of you helped me a lot on this one here. Julia, Kim, Ben, and Marcus especially. Thank you for that. Okay, I want you to work on this one, number 20, and we'll go over it in a minute. All right, what do you have to know for this one? What I did in my other classes today is I had this little visual aid of a roughly cylindrical object. So this is it. How do you find, what do you have to find of this object? A what and a what? A surface area and a volume. So does anybody remember what those formulas are? Or can reverse engineer what they might be? Is this the part of the day when everybody's tired and we're just done?
Yeah.
Is that usually this class really goes like to the end of class, but today maybe not as much. Maybe it's because we're into the midst of hell's library. You think so? Okay, well, let's talk about this. So try to stay with. Okay, how do you find the volume? What do you have to know first to find the volume? A what? A what? A height? What else did you say besides height?
Length and width.
Okay, yeah, that'd be like of a length and width times height would be the volume of a rectangular prism, right? So we're talking about this. So what do we have?
Circumference.
Well, circumference is going to come up a little bit, right? But,
No, diameter.
okay,
Then, we're trying to find
How do you find the volume of a cylinder then?
Okay, first we find the area of a square, of a circle.
okay, what is the area of a circle here?
Is it 2 pi? Well, something squared. Something squared.
Pi r squared, right?
And then you multiply that by the height.
Pi, okay, so we have it now, right?
No, I'll probably not that.
So volume
No,
is equal to pi r squared h. Okay, now the surface area, which we're also, now the surface area, we're talking about the area of what? The surface. We're talking about the area of that, plus the area of that, plus the area around, right? So how do we find such things?
Oh, the surface area?
Surface area. What is the area of the top of this thing?
It's a circle.
It is a circle, right? Which is pi r
Then
squared.
you find the,
So we got a pi r squared up here, we got a pi r squared down here.
you got a rectangle. I don't know how to find
So we got 2 pi r squared plus
the rectangle.
we got an area of it, because if you peeled off this label, you would have a rectangular sheet of paper, wouldn't you? That became the label, or plastic, whatever it is.
How do you find them?
Well, we know it's going to be the height, right? Because the height is part of it. What else do we have besides the height?
The diameter.
What is the length around? That is the width of that rectangle. What is the width, the length around? We've talked about it in problem 19. Talked about it in problem 19. We just,
Circumference?
the circumference, right? What is that circumference?
That's circumference.
Which is what?
Oh, I don't know. Like I know what it's like around it, but I don't know the one.
2r pi.
Yeah, 2 pi r times the height. So there we have it. So now we need to find the ratio of the surface area to the volume. And so surface area to volume is going to be 2 pi r squared plus 2 pi rh over pi r squared h. And what is that going to be? Well, it's going to be 2 pi r squared over 2 pi rh plus 2 pi rh. No, I've got it wrong here. I got it wrong here. 2 pi r squared h is what it is. Yeah. Plus 2 pi rh, that's where that goes, over pi r squared h. So what is this going to be here? What's going to be surface area over volume? Simplify this out, what do we get?
You get 2 over h
So 2 over h
plus
plus
2r.
2 over r. And then we have find the ratio when we have the radius is 3 inches, the height is 6 inches. It's 10 inches, excuse me. So we have 2 divided by 10 plus 2 divided by 3. So what is that going to be?
2630. Yeah. But also.
13, 15.
13, 15s, okay? So that's going to be, it's going to be it. Okay? So we have the rational expression, which is this thing right here, and then we plug these in, we get this. Okay. What I want you to do is work on 21 and spot the error. We don't have very much time left in class, but I'll call on somebody to tell me the error that is spotted. So look at that and spot your error.
She didn't do that. That's my thing, stop trying to steal it. You don't even do it right. It's not this.
Wait, what didn't you do?
Well, I can tell you, because then you're going to try to steal it.
So I have everybody here except for,
Stop trying to take that.
okay, I'm going to call on somebody here. Got everybody here except for, Connor, here we go. Somebody's going to tell me, one of you, I don't know who it's going to be.
It's going to be me.
It's going to be, now you wouldn't believe me. Addie, come over here, look at this. I want you to look, Addie, come over here, look at this.
Oh,
If
yay.
I could told the future, like he was going to have.
All right, go ahead.
You do it a lot.
He didn't flip the fraction into figures.
So didn't divide by reciprocal, didn't multiply by reciprocal, right? We'll just say that. We'll say Maria, we'll be generous, but we'll say Maria forgot to multiply by the reciprocal, right? By reciprocal. And that says correct her mistake. We don't really have much time to do that today, so we're going to have to leave it right here.
I got one.
Thanks, Zach's girlfriend.